Good afternoon. This is Math with Mr. Samuels. So hopefully everybody has their notes. We're going to go ahead and start focusing on laws of exponents today. Laws of exponents. So first and foremost, we're going to be discussing monomials. Okay, so what is a monomial? Okay, a monomial is a number a variable, sorry for that, or a product of numbers and variables. Okay. Let me give you a couple of examples before we progress. Give you a couple of examples. So -7 is considered a monomial. 3x is considered a monomial. 14xy is considered a monomial. X to the seventh power is considered a monomial. And one more example, -y to the fifth power is also considered a monomial. Okay, so now what we're going to do is we have monomials with the same variables and exponents are considered like terms. Okay. And one thing you're going to notice is in this video, I'm going to skip the next section. We're going to come back to this in a couple of days when we start talking about combining like terms. But for the ones that would like to just try to figure it out on their own really quickly, basically what we're doing is all we do is combine like terms. We can add the numbers in the front. So for the first example, 4x plus 5x, these two are considered like terms because they both are monomials that have the same variable and the same exponent. So 4x plus 5x would just end up being 9x. Okay. We can do the next one here as well. -12ab minus 2ab. Well, they're the same sign, so we're going to add them. And our final answer is going to end up being -14ab. Okay. You guys can go ahead and jump ahead and try to figure out those on your own, but I'm not too much worried about those because we're going to circle back to them in just a second. What I want to focus to is page 2. So page 2 is multiplying monomials, more so known as the product rule of laws of exponents. So to multiply monomials, use the product rule. So a to the x, a to the b. Remember that the two x's are our base. We have the same base, and the a and the b are considered the exponents. So all we need to do in this particular case is our final answer will end up being x. The base still stays the same, but the product rule states that if we're multiplying two exponents that have the same base, all we do is add their exponents, and that is our final answer. So a plus b. Okay. So let's look at a couple of examples down here below. We have 4 to the third times 4 to the eighth. Okay, 4 to the third times 4 to the eighth. Well, once again, we have the same exact deal. We have two exponents with the same base. So all we need to use is the product rule and add their exponents. So how we would show our work for this one is all we would do is we would simply say 4 to the, and we add 3 plus 8. And our final answer ends up being 4 to the 11th power. Now you can go ahead and use your calculator to simplify that. Okay, I'm fine with you leaving it as 4 to the x for right now, 4 to the 11th. I'm fine with you doing it like that, but you can write it. If it says leave it in exponent terms and leave it in exponent terms, if it says simplify, then you would all want to plug that into your calculator and simplify that. Let's look at the next one. We have -7 to the fourth power, and we have -7 to the fifth power. Okay, we have the same base and we're multiplying them, so we're going to use the product rule and just add their exponents. So just like on the last one, 4 plus 5 ends up being, 4 plus 5 ends up being -7 to the ninth power. Okay, I want you to go ahead and attempt the rest of those problems on your own. We're going to discuss them in class tomorrow or shortly in class if we watch this video today. Now, Down to the bottom is where we have variables as the base. And once again, nothing changes. Everything's still the same. The only difference is instead of having a number as the base, we have a variable. So let's go ahead and do an example. We have x to the second power times x to the fifth power. Well, once again, they have the same base, so we're just going to add their exponents. So our final answer is going to end up being x to the 2 plus 7. 2 plus 5. Sorry, my brain's working faster than I can type. And the final answer is going to end up being x to the seventh power. Okay, we can go ahead and do number 21 as well. Let's go ahead and do that one. We have m to the negative 1, negative 1 plus, can't see it, negative 1 plus 3. There we go. So now we think of our energy rules. Negative 1 plus 3 is going to end up being positive 2. So our final answer should be m to the positive second power. Okay. So now the only other thing on our agenda is still the same thing, but sometimes we might have coefficients. And if you don't recall, coefficients are the numbers that are in front of the variable. So right here, 4 is the coefficient on a. 2 is the coefficient on a to the third. Okay. Also remember, when there is no number in front of the variable, the coefficient that we have, or the imaginary number that's not written, is 1. So you got to remember that. So let's go ahead and look at this. So the rules, what we do when we have examples with coefficients, we multiply the coefficients, and then we simplify the variables with the product rule. So first and foremost, let's multiply the coefficients. 4 times 2 ends up being 8. And now we have to use the product rule to simplify the exponents part. So we have to the seventh power and to the third power. So a to the, all we need to do is add the exponents. So 7 plus 3 ends up being a final answer of 8a to the 10th power. Okay, remember, I'm using the caret to show exponent, but obviously you guys don't have to write that. Okay, let's do another example together. Let's jump down. Let's do one that looks nice and pretty. Okay, let's do number 32 together. I like that one. Looks good. So number 32 says 7c to the third power d to the second power times 2cd times negative 3 negative c to the third power d to the eighth power. Okay, so we have to first and foremost multiply all the coefficients. So 7 times 2 is 14, and 14 times negative, well, there's no number here. Well, what number is there? Negative 1. So 14 times negative 1 is going to be a negative 14. And now that we have negative 14, we need to combine all of our exponents using the product rule. So first and foremost, let's deal with the c's first. So the first exponent for c is 3. And we're going to add that to, well, this c does not have an exponent. So what exponent goes there? You are absolutely correct. 1 goes there. And last but certainly not least, the next one that we have is c to the third power, which is plus 3. Okay, so now we can deal with our d's right next to it. So the first one has d to the second power. So d to the second power. So 2 plus d to no exponent, which we know that is 1. And the last one is d to the eighth power, so plus 8. So our final answer ends up being negative 14 c to the seventh power d to the 11th power. Okay. And the correct way to write that, let me use my drawing tool. The correct way to correctly write that would be negative 14 c to the seventh d to the 11th. So now what I want you to do is I want you to go ahead and attempt the rest of them right now in class, and we're going to discuss them before you guys leave and practice this a little more tonight. This has been Math with Mr. Samuels. Have a great day.